Hey guys, we're looking at log graphs today and more importantly their transformations. So I've done my usual summary of all the different numbers and how they can affect our log graph, but before we do that, let's just look at what I call the perfect log graph. So Extension 1 students, you probably recognize this as the inverse of the exponential along the line y equals x, because the log is an opposite of an exponential. Otherwise, some of the qualities that it passes through zero. Why does it pass through zero? Because if you do the log of 1, you get 0. Pardon me. So, you can't take the log of 0. All right, it's an error on your calculator, which explains the asymptote that we have there along the line x equals 0, or the y-axis. All right, now let's look at how things can transform it. So I'm just going to stick with my ln. I just like using ln. If I then took the negative of ln, or the negative of log x, same thing as anything else. It flips it upside down. So imagine this flipped upside down. It's going to then instead look something like that. Okay, what about then if I did the same thing, y equals log of x and I plus 1? Actually, let's do plus 1 outside the brackets. There's a big difference between them. Plussing 1 on the end of any function we know shifts it up 1. So what I know is my new graph will pass through at 1, 1, and I'll label that there. But then obviously it's just going to be 1 unit above the rest of this graph here. Okay, so if I do that, it's going to look something like that. And let's have a look just to play around for a second. If I want to find that x-intercept, well, I know I find an x-intercept when I make y 0. So I'd have 0 equals ln of x plus 1. If I was to solve this equation, then I could rewrite this onto the other side. I'd get ln of x equals negative 1. If I solve this equation and write it in exponential form, that would be e to the power of negative 1 equals x. So therefore, x equals 1 on e. So I know that that x-intercept is 1 on e, if I really needed to find it. But today I'm more focusing on just you knowing the transformations. All right, so then what happens is if we have, let's say, log of x plus 2. What happens here is it's in the brackets. So just like anything in brackets, it shifts it in a horizontal direction, in the opposite way though. So this is going to pick up our log graph and shift it into the negative 2 direction. So it's going to pass through, think it's already passing through 1, so if I subtract 2, it's going to pass through at negative 1, and then it's just going to have, and this time, and I would sketch it, my asymptote is at negative 2. And if you check, you can't take the log of 0, and that would make sense if you have x being negative 2 there. So very similar qualities to anything else. The only other one I'll show you is, I'll do this one in yellow, if we had y equals log of negative x, say. So just like anything, when we sub in a negative x into the function, this time it flips it along the x-axis. So we know that a negative at the front of the entire graph, like the blue one showed, it just flips it along the x-axis. But a negative in where the x is flips it along the y-axis. So our graph for y equals log of negative x, it flips it along there, passing through this time at negative 1. So it takes that normal log graph, flips it over. So then you could imagine the graph then, I'm running out of colours here, y equals negative log of negative x, imagine that. It's just going to be our yellow graph here flipped upside down. So it would be like that, passing through at negative 1. Okay, so hopefully now you can come up here and see how this summary is definitely going to help you with that idea. You can add in, I didn't mention the f of negative x and the negative f of negative x. You can add those sketches in from what I just spoke about if you like. But otherwise, the one I didn't do is an A value. I'm running out of room a little bit here, so let me just come down. I'll just quickly sketch my dodgy, so that's my y equals log of x. The only one I didn't talk about is not as common. What about 2 log of x? So we know that generally the 2 out the front makes something steeper, so twice as steep, okay? So I'd think of it in a very similar way with the log graph here. It becomes steeper, so it will look something like this. Not great, but the thing is, it still has an asymptote at the y-axis there, so it still will eventually come down there. Definitely not a good drawing there. Passes through the same intercepts, has the same asymptotes, but it's steeper. So you could imagine that if I did then y equals a half log of x, this time it's shallower and would go like that. Now, the only last part is what happens if they, like these are all with a base of e, okay? But what happens if they got you to sketch something like this, y equals log 5 of x? Well, the idea is they have the exact same transformations as what we've just dealt with. But if I had something like this, I would keep in mind all my transformations. So I say to myself, okay, nothing is really affecting it. It should look very, very, very similar to our normal log e graph. But you can always do a table of values. If you do a table of values, you're thinking, okay, wait, but I don't have that number in my calculator. So remember, if I don't have a log with a base 5 in my calculator, I can do my change of base, which is then going to be log of my big number over, and this is log e or ln, log e of the small number. So in your calculator, when you have, say, -2, -1, 0, 1, 2, you're just going to be putting that -2 in where x is here, okay? And doing your log e, and that'll get you the value. And then you can plot your table values. But it'll still come out with the same idea, same shape and everything as our log e of x. And so that way, if you had to graph y equals, say, 2 log 3 of negative x, straight away I'd be thinking, okay, pretty steep, and it's going to be flipped along my y-axis, so it's going to look something in this direction. So I keep those transformations in the back of my mind, but when it doesn't have a nice base, don't forget to just use change of base. So today's exercise is exercise 806, and I want you to have a go at questions 1 to 4, all letters. See how you go with that.